Hello everybody, welcome back. Today we're going to finish up 7.7 with example 3 and 4, determine the exact value of the solution to a quadratic equation. So this is where we end up, we don't have a square root underneath the square root sign, so we have a radical. So we did that in grade 10, so we're going to take a peek at that and see how it unfolds. So the same idea, we started off, we label A, B, and C, we enter them into our quadratic formula. A, and then B is 8 again. So I don't need a bracket if it's a positive, right? Oh, that's 8 squared, sorry. 8 squared. A is 2. And C is -5. And A was 2 again. Okay. So, first step, I substitute everything in. Second thing we'll do is start to solve. -8 is just -8. 8 squared is 64. And -4 times 2 is -8. -8 times 4 is, -8 times 5 is 40, right? Positive 40. And then the denominator is 4. So the next step, we take the 64 and 40, add it together, we get 104. So normally this is where we split it, and the plus and minus, right? But the square root of 104 is obviously not a perfect square. It's going to be 10 decimal something. But you may recall in grade 10, when we did radicals, we were simplifying radicals. So that's what we're going to do here. We're going to take this radical, 104, and we're going to simplify it. So to simplify this, what we're going to do is we're going to write the factors. So the factors of 104 are 1 and 104. Neither is a perfect square. Remember, look for perfect square factors. All right. And 2 and 52. 3 is not a factor, obviously. So 4 and 26. So there's our first perfect square factor right here in the bold, number 4. See if there's any more though. We keep continuing. 5 is not a factor. 6 isn't a factor because 3 wasn't. 7 doesn't work. 8 and 13 would be factors. Neither are perfect squares. 9 is not a factor, and obviously it's not 10 because it's 10 decimal 2-ish. So those are the factors of 104. So if you recall, we want to rewrite this 104, square root of 104 as the square root of 4 times, and we show that with a little dot if you remember, multiplied by 26. And then we split this into 2 separate radicals. And again, some of you might be able to do this step no problem, right? Then we take the square root of 4, which is 2. And nothing we can do with the square root of 26. That's as low as we can simplify that, so that's finished. But we can simplify this part here, so this is where we're going to split. All right. But before that, we know that 8 divides into 4 twice, and 2 divides into 4 twice, right? Or sorry, a half, right? So this 8 can be simplified to 4, and that is a 2 if that goes to a 1 like that. Now, some people like to split them separately, and I completely understand why, and I'll show you. So right now is where we're going to split them into 2, because sometimes one will simplify and the other will not, I guess, is what I'm trying to say. So I'm going to simplify these now. Remember, we'll call this x1, x2. If you're okay with just leaving them as x, I'm fine with that as well. There's x1, and there's x2. Remember, when you split them, one becomes plus, one becomes minus once you split them. And what I talked about before was when you were simplifying these, okay, what essentially this means is this 8 is divided by 4, right? So basically what it looks like is -8 divided by 4, and then the plus 2 square root 26 all divided by 4 as well. So So some people like to split it like that, and I'm okay with that as well. I think that's a good idea. Just to understand that it represents two different fractions there, essentially. So this 8 divided by 4 is actually going to be simplified into a 2, and this 2 and 4 would simplify down to 1/2, right? There's a 1 here, but you don't need to show that, and it would look like that. And this side would be the same as well. Remember, the 2 over 4 simplifies to 1 over 2, and that's what it would look like, okay? And normally, if you get a whole number at the front, that's what they'll show. But again, it's okay to leave it with the simplified as both over 2. But I like to show it like this with the whole number, the integer value if possible. Again, it'll just depend on what you see, right? So what I mean by that is, again, you can simplify within, and I've seen it simplified both ways. Remember, this would be divided by 2 to give you 4, because the lowest we can make that is a 2, and that would be a 1. And these are equivalent, by the way, right? So I've seen it simplified both ways. This is my preference right here, but they are all equivalent, okay? And that's it for example number 3. So if the square root doesn't, if it's not a perfect square, then you simplify the radical like you did in chapter, last year in grade 10. Excuse me. That's so solving a pricing problem. So this is kind of like the problem we did before with the pierogi, if you remember. But this time I gave you the revenue equation. So revenue was equal to, so for every $1 increase, they rent 30 fewer games, so they're trying to find that maximum. So can the owners increase the rental enough to generate $7,000 per month? So what we're going to do is we're going to find the maximum, and we're going to do that via the quadratic formula, because that's the section we're working at. All right. So the first thing what we'll do is we'll fill in everything we know. So we take our formula. Here it is. Okay. And then we're going to plug in everything we know. So I've rewritten my formula. Now we're going to plug in what we know. So we're going to solve for P here, but we know the revenue. We're looking at revenue of $7,000 per month. Okay. So now we're going to do the distributive property here and set this equal to 0. So it'll be 4.5 times 750. Plus 4.5 times negative 30p. Then it's going to be P times 750 and P times negative 30p. Right? Distributive property. We'll clean this up and then we'll subtract the 7,000 from both sides. So 4.5 times 750 is 3375. Oh, sorry. 3375. Negative 4.5 times negative 30p. So we take 4.5. Already we have negative 130, or sorry, positive 135p, because of negative, or that's positive, sorry, that's going to be negative, I apologize, negative 135p. And then 750 times p is 750p. And negative 30p times p is negative 30p squared. Okay? All right. Oh, that was a 5. I forgot. I missed that. Sorry. 3,375. So now what we're going to do is we will collect any like terms. All right. Collect any like terms. Might as well subtract the 7,000 first. Again, we could have did that at any point, but might as well do that now. And that's eliminated, and then we end up with, that's a 0, obviously, that's why we did it. We want to get one side equal to 0. subtract these, we get negative 36.5. Add these together and we get 615p. And there we are. And if you want to put them in descending order, so the exponents are in the right place, that's fine with me. So that would mean I would take this and cut it there, just so you won't mix up the A, B, and C, right? Take the sign to the immediate left with it. So these numbers are really large. So what I noticed that they all end in a 5. So what I did was I'm going to simplify this, right? Because we're dividing by 0, we're allowed to do that, right? Well, sorry, because we're equal to 0, what we can do is we can factor out a negative 5. Okay, so if we factor a negative 5 from the whole thing, we're going to end up with 6p minus 123p plus 725. Right, so I factor a GCF here. Again, this is just going to make your life a little easier, right? And what you can do is you can have an A value of 6 instead, a B value of negative 123, and a C value of 725. Now again, if you use these values here, you didn't recognize to divide by the, factor with the negative 5, that's fine, it'll still work, just your numbers are going to be a little larger, that's all. But your X values will end up being the same, okay? So we'll put B in at negative 123. Negative 123 squared minus 4 times 6, and our C value is 725, and our A value is 6. Okay. Then we'll clean this up a bit. So a negative ends up being 123. 123 squared. I'm not sure I do that one quite in my head. 123 squared is 15,129, and negative 4 times negative 4 times 6 times 725, that gives me a negative 1740. Denominator is 12. You're probably seeing what's happening here. And again, we're going to explore this more in 11 pre-cal. So we end up with negative 2,271, and you got to stop here. You'll notice that this will give you an error, right? So remember that since the radicand is negative, okay, we learned this last year, you can't take the square root of a negative number, we know this, right? So we end up with negative 2271 is not a real number, right? We learned that it's actually called an imaginary number, and again, we're going to talk more about this in pre-cal 11. But if that's the case, there are no real solutions. So essentially, it doesn't cross the x-axis. So if that's the case, it is not possible for the store to generate a revenue of $7,000 per month by increasing the rental rate. Okay? So that's not possible. So if you end up with the square root there, that's what's occurring. Okay? But like I said, we're going to explore that more in pre-cal 11. So that's it for 7.7. There's some homework there for you to try some of those questions. It's on page 427, numbers 1 through 11. Okay? All right, hope the videos help, and in the next video we'll talk about the last section, which is solving problems using these quadratic models. So we'll talk again soon. Thanks everybody for watching.